Welcome back, friends. We are continuing with systems of equations and with graphing. So we've talked about what is a solution, how can we get it on a graph, we're looking for those intersections. But remember back in equations, way back in chapter 1, we talked about how equations can have different types of solutions. And there was 3 of them. They could have one solution, they could have no solution, or they could have infinitely many solutions. And the same is true for systems when we have two equations on a graph. So up first, when they ask you to determine the solutions, you need to put them on a graph. You're going to have to actually graph both lines. So here's an example of 2 lines that have been graphed. So it is a system. And I need to know, do they intersect? And I'm looking and I'm like, well, they look like they intersect to me. Do they look like they intersect to you? Yeah, they intersect right here. So this has a solution, and it only crosses one time. That means it has one solution. And in this section, you're just going to tell me, is it one solution? Is it no solution? Or is it infinite? Now, you could name the solution, but you only have to name the solution if it's asked you to name the solution. So for instance, I now have a new graph. And if you notice, these are great ones. These are Hoy. Remember Hoy? Horizontal, slope of 0, and the equation always says y equals. So we have 2 equations here. Now, these have the same slope. They both have a slope of 0. And because their slopes are both 0, and they're away from each other, they have a different intercept. That means they're never going to touch each other. They can't. They're never going to cross. Ever. And if they never cross, they never have any point or coordinate that makes both of them true. So if you remember way back when, we would use the little null set, but typically you would just see something that would ask you to type no solution, because there is no way that these lines are ever going to touch each other. Then you might see something that looks a little bit more like this. You see the blue and the yellow, and they're kind of stacked on top of each other. That's because they're the exact same line. Look at the equations down here. Y equals negative 3/4 x and y equals negative 3/4 x. They're the same line. Now when you see these, they won't always have them both in the same form. So they might be a little sneaky. So you might have to change them into y equals mx plus b to see it. Or if you graph them, it's easier to see. But if the lines are right on top of each other, and yes, if you need to graph lines that are the same, you have to graph both lines and put them right smack dab on top of each other. You have to stack them. And when that happens, how many solutions do we have? How many times does one line intersect with the other? Hopefully you're thinking infinitely. It doesn't matter what point, and remember a line, it represents everything, even the points you can't see. So every little thing on this line, every little coordinate, every little piece of this line is touching the other line. So this is where we would use that infinity sign, but remember it will also just say infinitely many solutions. So right back like we had equations, you could have one solution where they just touch once. You can have no solutions where they're actually parallel to each other, or you could have infinitely many because they are stacked right smack dab on top of each other.